Okay, hi, welcome to my talk. And my name is Axel. I work for Code Manufaktur GmbH, and the title of my talk is "And Now the Testing Forecast: Scattered Patches of Pain." And as you probably can tell, this is a reference to weather forecasts. The reason why I choose this is because I spent a year in the UK and I was always fascinated by the weather forecast, which to me actually sounds like poetry. So you have the scattered patches of pain, you have sunny spells, you have the odd shower, but let me tell you, the scattered patches of rain can be really annoying. So for example, if you have, well, but luckily we have the weather forecast. So they make predictions about the upcoming weather a lot more, they make it very helpful. So they tell you what kind of weather to expect, where and when to expect it. And actually they also tell you how reliable the prediction is. Even if the weather forecast is not always 100% right, it's very helpful. You can make better decisions going forward. So if there is the odd shower in the Great British summer, you can bring an umbrella to the beach so you don't get wet. And you also don't have to buy an umbrella. Okay, now for something completely different, or maybe not. Can it also work to make predictions in agile software development projects? Well, the reason I'm asking this question is because it's something I've been working on for a while now. And okay, let's look at software development. Things are rather simple, right? Developers make code changes, they trigger software tests. Tests provide important feedback to the developer and sometimes lead to defects, and then the developer works on the defect or on other issues and so forth. But, well, unfortunately, it's not that easy. Things are not so simple. For example, if you have software tests, time is a limiting factor, and developers are often waiting a long time for test results. Why is that so? Because tests may not only take minutes, but they can take hours or even days. And well, we want quick feedback. And the other limiting factor, of course, is computational test resources. They are scarce. Developers have to wait for the test server to become available. And this prolongs testing time again. And again, we want quick feedback. So what would be cool would be a system that predicts test results for code changes. How would that work? Developer sends the new code to this great system. The system immediately predicts tests that will probably fail. And then again, you can make better decisions going forward. Why would this be helpful? Well, it's obvious. As a developer, you can, for example, run that test which is predicted to fail. And if it fails, you can fix your code. So this is exactly your umbrella. But there are other things that you can do. For example, you can, if you run your test suite as a tester, you can reorder test execution. Of course, the idea is to run the critical tests first and to get quicker feedback, which is there a problem in my patch? Is there a problem in my commit? Okay, that having said that, what the question is now, how are code changes and tests connected? And this is maybe easy for unit tests because they test a certain part of the code, but it's not easy for integration or system tests, obviously. And these are tests that are long running, and that these are the ones that really hurt you. Okay, but this is where things get complicated, because on the one hand you have code changes, but you also have you make these changes in multiple files. You have software components. The software components are released from time to time, and of course there are also developers, branches, and so forth. And well, there are a lot of interdependencies. This graph, for example, shows you nodes which represent a version of a software component, and the connections between those nodes are dependencies to versions of other components. And this changes over time, of course, and that's why it gets so complex. And well, it gets even more complex if you look at more interdependencies. So this graph actually is reality. This is a visualization of reality. What's my point here? My point here is, of course, for a human being, it's impossible to keep track if things get more complex. So how can we actually still use this data, even though it's hard to keep track as a human being? We have data from source control, we have data from test management systems. How can we still use this data for test prediction? And well, the answer is machine learning. With machine learning, it's possible to learn patterns from existing development data, and you can do that with standard machine learning algorithms. That's the good news. You don't need the super specialized weather or climate model to predict the weather. Okay, and in other words, what you can do is you can use machine learning and train your system to make test predictions for new code. This will give the developer quicker feedback, and it helps to make better decisions going forward. So how does this work in practice? Here's a quick example from a real world project from the healthcare sector. 500 developers are committing code at least once a week, and there are over 70,000 test cases, and it works. The system performance is better than 70%. So quite good to make predictions. And so to sum up, what do we recommend? Make use of your data, create predictions in your software development projects, and then you can make good decisions and avoid the scattered patches of pain. Thanks a lot.